Hello, grade 10 learners. Our topic is on theorems on chords, arcs, central angles, and inscribed angles. At the end of this video lesson, you are expected to define and illustrate congruent circles and congruent arcs, define and illustrate theorems on chords, arcs, central angles, and inscribed angles. Now let's start. Let us begin by defining congruent circles. Congruent circles are circles with congruent radii. For example, line segment AB is a radius of circle A. Line segment EF is a radius of circle E. If line segment AB is congruent to line segment EF, then circle A is congruent to circle E. What are congruent arcs? Congruent arcs are arcs of the same circle or of congruent circles with equal measures. For example, in circle A, arc CB is congruent to arc DE. If circle A is congruent to circle O, then arc CB is congruent to arc ST, and arc DE is congruent to arc ST. Let us deal with theorem on arcs and central angles. In a circle or incongruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. For example, if circle A is congruent to circle O and angle CAB is congruent to angle DAE and congruent to angle SOT, then arc CB is congruent to arc DE and congruent to arc ST. Now let's move on to theorem on arcs and chords. In a circle or incongruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. For example, if circle A is congruent to circle O and line segment CD is congruent to line segment BE, congruent to line segment ST, then arc CD is congruent to arc BE and congruent to arc ST. Theorem on arcs, chords, and diameter. In a circle, a diameter bisects a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. For example, in circle A, line segment CF is the diameter and line segment DE is a chord. If CF is perpendicular to DE, then line segment DB is congruent to line segment BE and arc DC is congruent to arc CE. Let us deal with exercise number 1. If the measure of angle COD is 113, find the measure of angle FOV. Since COD and FOV are vertical angles, therefore, the measure of FOV is 113. For number 2, what is the measure of angle COF? Since COF forms a linear pair with COD, it means that they are supplementary. So, the measure of angle COF is 67. What is the measure of angle DOB? Since COF and DOB are vertical angles, it means that the measure of angle DOB is also 67. Now let's move on to the theorems on inscribed angle. Theorem number 1 states that if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intersected arc, or the measure of the intersected arc is twice the measure of the inscribed angle. Given the figure, in circle A, angle ECF is an inscribed angle and arc EF is its intercepted arc. If the measure of arc EF is 120, then the measure of angle ECF is equal to 60. For theorem number 2, if two inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent. Given the figure, in circle A, angle ECF and angle EOF intercept arc EF. Since angle ECF and angle EOF intercept the same arc, the two angles then are congruent. For theorem number 3, if an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. Given the figure, in circle A, angle ECO intercepts arc EFO. If EFO is a semicircle, then angle ECO is a right angle. For theorem number 4, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Given the figure, quadrilateral EFCO is inscribed in circle A. Angle ECO then plus angle FCO is equal to 180, and also angle EFC plus angle EOC is also equal to 180. Now, for your exercise, try doing this on your own. If the measure of arc LE is 124, what is the measure of each of the following angles? Until our next session, thank you and enjoy learning.